Hello, Professor. This is my lab for the array project. This is my data section. We use the Irvine library. My data section, I use the array with double word, 100 duplicates, the count, double word also. I use a prompt for the elements, also a prompt for wrong entry, a prompt for invalid entry or invalid integer, and also another prompt for when they're entering each element, a space prompt for legibility. And this, anything highlighted in yellow is for the extra credit, the 3 points extra credit for entering elements in ascending order. And I would try to go through that as I go along through the explanation of the original assignment. I also use the prompt for sorted array, a comma prompt just for legibility as well. Another prompt that reads the gaps are to print the gaps. A sum doubled word I initialized to 0. That's for the final part of the assignment is to sum up all the gaps of the array. I also have the sum out printout, and this is the sum printout, and a new line uh, printout. So just for legibility. In my main procedure, I start off with, I labeled all the blocks with an explanation pretty much. This is where we get the number of elements and we validate as well. Then the elements, the input must be 2 or greater because we're adding up the gaps. So in order to have a gap, you got to have at least 2 elements. So we print out the prompt, which is this one. How many elements do you want to enter? It reads the integer. If it's an integer, there's no overflow. It's going to go to good int. It's going to compare right here if it's negative. If it's negative, it retries. So it starts here again. If it's not negative, then it compares EAX to 1 because it needs to be greater than 1. So if it's equal to or less than 1, it's going to retry. It's going to go to retry 1. If it's not less than or equal to 1, then it must be greater than 2. So it's going to continue, and it's going to move the value of EAX into count, the variable count. And that's going to give us our number of elements. After that, we go to taking input from user and validating for the array. We use 1 into EAX because we're going to use it to compare to count. We're going to set ESI to the beginning of the array. And then again, this yellow section is for the ascending order assignment. And we're going to use CBX. Right here, we're going to set it to 0. But that's for the other assignment. So we start with the label element loop. This is where we're going to use this section to ask the user to enter the first element or all the elements, but it starts off with the first element. So that's why we use ECX, and we put 1 because it's going to print out enter element, and then it's going to say we're going to move ECX into EAX, so it's going to print out EAX, which at this point is going to be 1. And then we're going to increment it later somewhere down here. So this could say 2 and then 3 for the next, the following elements. Again, this is for the ascending order assignment, where we would print something that says in ascending order after the number of elements. So we're going to put a space also. This is a space for legibility between the prompt, and then we're going to leave a space between the prompt and the input for legibility. So right here, we read the elements 1 by 1. Every time you input it, it's going to read it. If it's no overflow, it's going to jump to good element. If there is an overflow, it's going to send you back here again. So when it's a good element, it comes here. We test to see if it sets off a negative flag. If it does, it jumps right here, which then again prompts you for the element and the number. I mean, the element. No, it gives you a prompt that it's the wrong entry and it sends you to element loop, which is going to ask you for the number of element again, the element number 3 or whatever. If it doesn't jump, if it's not negative, then it's going to save the value of EAX into the beginning of the array, the first spot, or whatever ESI is pointing to at the moment. But right here again, for the 3-point extra credit assignment, if it's not a negative number, it's going to compare it to EBX, which at this point would be a 0. And so whatever the first iteration, whatever EAX is going to be greater than 0. So it won't jump, but let's say it's a 2 at this point, then EAX would need to be greater than 2. Otherwise, it's going to jump back. So if it's in the original program, we're going to save it into EAX. EAX, we're going to save it into ESI. And then we'll continue down here and add 4 to ESI and increment ECX so we could print the number 2 or 3, the following number. We're going to print it when we ask for the elements. And then we're going to compare ECX to count. And then if ECX is less than or equal to the count, then it's going to jump back to element loop, which is right here, and continue the process again for each element until we're done with all the elements that the user input at the beginning. So this comment block right here is to explain these the ascending order element of the extra credit. Let me explain it real quick. So let's say EAX is less than EBX, it's gonna jump, right? If it's not less than, let's say it's greater than EBX, then it's gonna save EAX into ESI, and then ESI value, whatever EAX was, is gonna save it into EBX. So in the next iteration, EAX is gonna have a new value and it's gonna compare it to the old value, which would be in EBX. And therefore, if it's less than, it's gonna jump. If it's not, it's gonna continue. And that's what I'm explaining in this block right here. So after it's done and ECX is greater than count or equals to count, it's less than or equal to count. Okay, if it's greater than count, it's gonna go here to sort the array in ascending order. And we're gonna start here with a count, putting it into EBX, and then decreasing it. The reason why we're gonna do that is because we're gonna sort it. So in order to sort, we would have to loop the amount of elements minus 1 in order to sort this. So if we got 5 elements, we're gonna loop in the outer loop. We're gonna loop 4 times in order to go through all the elements one by one. So that's why we decrease EBX right here, which is count. We decrease the count of the elements. So we start off with loop 1. We use EBX and we put it into the count. Into the counter ECX, because down here we're gonna use a loop for the inner loop. So we're gonna put the ESI into the beginning of the array. We're gonna move the beginning of the array value into EAX, and then we're gonna compare EAX to the next value in the array. And if it's less than the next value, it's gonna jump to next. If it's not less than, then it's gonna exchange the 2 values. And then it's gonna move the value of EAX into the beginning of the array. So it's gonna take the next element, put it into the EAX, and save EAX into the beginning element, into the previous element. So it's less than the previous element now, if I explain myself. So after it does that, it goes to next and then adds 4 to ESI to move to the next location in the array, and then it loops to loop 2. And it's gonna go like that one by one, and then when I'm sorry, yeah, it's gonna go one by one all the way around. It's gonna go through the whole array the one time, and after 2 loop 2. Yes, when it loops, ECX decrements by 1. So then after ECX equals 0, it's going to continue. And that's when we're going to decrement EBX by 1. And then it's going to jump to the beginning of the outer loop again. And this is where we move EBX again to ECX, because now we're going to do one less count of ECX in the inner loop, because we already moved to the next element, and we start at the next element and do the same thing again into pretty much into EBX equals 0. Then it's going to continue. It's not going to jump back to loop 1. And that's where we start printing this sorted array. And we start off with moving 0 into ECX and putting ESI into the at the beginning of the array. And we set the prompt, the sorted array is, and then we're going to print it right here. ESI will be the beginning of the array, and we're going to move that value to EAX and print it out. Then we move we move ESI to the next element 4 bytes later, and then we increment ECX, and we compare ECX to the count, which is the number of elements, and we use this comma 1 label to print out a comma and like for legibility, a comma in between each element. So if ECX is less than or equal to count, it's gonna jump to comma. If not, it's gonna jump to calculate gaps, which is down here. But when we jump to comma, then we print out the comma, and then we jump to loop, print loop, and then it does it again until it prints out all the elements. Once it's done printing all the elements and ECX is greater than count, then I'm sorry, if it's equal to or greater than count, then it jumps to calculate gaps. And then from here, we calculate the amount in between the gaps. So we print a new line for legibility, we print the gaps are, and then we start first calculating the gaps so we could then print them. So we put 0 into ECX, and then we subtract 1 from count, because again, we want to calculate the counts. That means if there's 5 numbers, we're only going to count 4 gaps. So count is the amount of numbers we have, so we're going to subtract 1 from that. And we move ESI to the beginning of the array again, and we start calculating the value. So we're going to move the beginning of whatever values at the beginning of the array, we'll put it into EBX, because we're going to do some arithmetic right now. We use the second value and we put it into EAX. And because right here it's already sorted, EAX is always going to be greater than the value before it. So we're going to subtract EBX from EAX, and then we're going to print that number. So the EBX is 2, EAX should be greater than 2. And let's say in this case, let's put 4. So it's going to print out 2. Then for the example, the 2 is going to get saved into EAX, and it's going to sum it to 0, which at this point is, to sum, which is 0 at this point. So sum is going to equal 2 after this instruction. And then we move the location of ESI to the next value. And right here, I use XOR to clear EAX and EBX. I incremented ECX to compare it to count, which is count minus 1 at this point. And then the same thing with the comma. We print a comma in between each value. And then comma, it's going to make a jump to calculate again. So we're going to do this with the next value, with the next gap until there is no count. If there's no comma or ECX equals count, we're not going to print the comma. Therefore, it's going to jump straight to some array, which is over here. And right here, we print a new line. We set the prompt, we print out the prompt. This sum is, and then we use whatever accumulated in sum, and we put it into EAX to print it out. And that's the end of the code. We finish right here with the main procedure, and then we end the main. So let's go to the actual code to run it. So this is my code. Same thing that we just went over. Let's run it for test purposes. And let's use the input from the lab assignment, which is, I have it right here, give me a second. Okay, the first value is -15. It's going to give us the wrong entry. Try again. Then we input of 5. Then that gives us a prompt for the first element. We put a 9, then a 0, and a T is going to give us invalid integer. So let's try the 3 again. We're going to put a 2, then a number 10, and finally a number 5 will give us the sorted array is 0, 2, 5, 9, 10. So it sorted these numbers and put them in order with a comma in between. The gaps in between these are 2, 3, 4, and 1, 2, 3, 4, and then between 9 and 10 is 1. And then the sum of these equal to 10. And that's the assignment for the week. Thank you, Professor. I'll see you in class.